So today I'll be talking about the muscles. So then there is a muscle fiber, and then within those muscle fibers is myofibrils, and there can be many of them. And they're kind of circular and like cylinder in shape. They're long. And within that myofibril, there are filaments. There is actin filaments and myosin filaments. And so those myosin filaments are then referred to as the thick filaments, and the actin filaments are referred to as the thin filaments. So myosin, they have actin binding sites on them, and then they also have two heads on it. And then actin, it has troponin, which will then unwind the tropomyosin, to which then calcium can then jump on the troponin. And actin, it's almost twisted up in a way. And so then we get into when your body wants to contract. So then your brain's going to send a signal. And so like we've been talking about your bicep muscle. So then your brain is then going to send a nerve impulse but technically an efferent signal into the neuromuscular junction. And so then it's going to travel down an axon terminal, and then it's going to go into the synaptic vessels. And so there's a gap in between, so there's a gap in between the actual muscle itself and the ending of the muscle fiber. Or not the muscle fiber, the nerve fiber. And so that is called the synaptic cleft. And so what's going to happen is that the synaptic vessel is then going to release acetylcholine, which is also referred to as ACH, and it's then going to travel down into the motor end plate of the actual muscle, and this is going to open the sodium and potassium gates. So then after that, sodium ions will then start to enter the sarcoplasm. So sodium will then enter and potassium will then go out. So then it's almost like a bridge, kind of like if one thing goes out and if one thing goes in, another is going to go out, which will then enter into depolarization. And so the inside of it will become less negative than it was before. So let's say originally we were at -90. That sodium is then going to start bringing it up to like -70, -60, -50 until we're in the positives. And then after that, so at first I was in the sarcolemma, and then it's going to now travel down the T-tubules, which will then transport it into the sarcoplasmic reticulum. The sarcoplasmic reticulum, the significance about that is where calcium is actually stored, which calcium is needed for muscle contraction. And so at this point, so then there's going to be that excitation that goes down the T-tubules into the sarcoplasmic reticulum. And so once that happens, calcium will then start to be released. And so because there's a release of calcium, troponin will then open up those binding sites, which will basically unwind the tropomyosin, so then calcium can then bind to those troponin. And then once that happens, a myosin filament will then bind to an active filament. So then the heads of those myosin will then bind to those binding sites of the actin. And so with that, like, it's going to cause that sliding motion. And so it's not like, okay, so let's say this is your muscle. It's not going to all be one thing. Like, this part's going to slide, and then this part's going to slide, and then this part's going to slide. And like, there's multiple parts sliding in together to make that contraction. And so once this happens, ADP and a phosphate is then going to bind to those myosin heads. And the reason for this is because then it will be converted into ATP. And once it converts into ATP, then that myosin head will be able to release from the active binding site, and so basically it will release that actin filament back to normal. And so instead of being contracted, it'll then start going back. so that then this contraction can then be repeated for whenever it needs to be repeated. And that is all. Thank you.